Morgan.
And I'm Kalia. And together, we're super professional scientists. Morgan, do you see those waves?
What's a wave?
Have you ever thought about waves scientifically?
No.
Would you like to learn?
Tell more, please.
Bet.
The anatomy of a wave is quite simple. There are four main parts to a wave: the crest, trough, amplitude, and wavelength. The crest is the highest point in the wave, and the trough is the lowest point. The wavelength is exactly what it sounds like: the length of a wave from crest to crest. The amplitude is the wave crest to the baseline.
See? Waves.
But, what is a wave physically?
Well, waves are essentially energy moving through matter. Even though waves look like an ideal transverse wave, they are actually more complex. Water waves are actually orbital progressive waves. The way waves are created is mostly by wind. Water molecules that make up the wave move in a circle or orbit, moving up the wave, then right, then left, then...
Wait. So you're telling me that waves are created with wind?
and other contributing factors.
So there's not like a big machine in the middle of the ocean like Kelly Slater's, surf ranch?
Who is that? Anyway, okay. If you're not understanding this, let's do an example. This example is a very, very, very dangerous experiment. It should only be performed by professionals like me and my partner here. Now, this is how you create waves. What you want to do is you want to get your beak. Just kidding. All you gotta do is blow on it. Waves, bull. The transfer of energy from wind to the water makes peaks and white caps in the water surface. Storms have a greater impact on the wave with higher winds and more agitation to the water. Waves travel in a line called wave trains. These waves don't all travel at the same speed, though. Sometimes waves catch up to each other, creating an even bigger wave that is called a constructive interference.
Wait.
Stop interrupting me.
Like football? Passing interference!
Oh. So now do you understand it? Physics, waves?
Waves, ocean, sand, beach, surfing!
Girl, what are you talking about?
The physics of surfing.
No, we're doing the physics of
No.
waves.
That would be so good for our video.
No surfing, no.
Let's go visit some professionals, my little surfer buddies.
Fine.
Yeah.
I think where'd Morgan go? I think I found a surfer in their natural habitat. Let's see what they do. Hey!
Started.
Can you come help me with this video?
Yeah.
Are you a surfer? Hold on. Are you a surfer?
Yeah.
Yeah. Come help me with this video.
Yo!
Oh no.
Sorry, dude. Virginia has no waves. I was just taking a little snooze.
Oh my gosh, you look. Anyways, so my friend told me that I actually don't know where she went, honestly. But she told me that you're a surfer. She has surfer friends. Do you know her, Morgan?
So yeah.
You need to take a shower, hon.
I don't.
How long
It's not. It smells like the ocean. Free spirit.
Okay. So I was hoping that you could show us or talk to us about something about physics of surfing, if you know anything about that.
Yeah, bro. I got you.
Okay.
Surfing consists of four main parts: gravity, buoyancy, torque, and the waves themselves. Gravity and buoyant force work together to keep a surfer on the board. Gravity pulls the surfer onto the board, and buoyant force keeps the surfer afloat. The buoyant force acts upward on the board as gravity acts down on the board. They both work on the same object at the same time in the same spot.
Check this out, little bro. Buoyancy versus gravity. Whoa.
Torque constantly undulates underneath the surfboard, creating additional varying and unpredictable hydrodynamic forces that act on all parts of the board. Any force that acts on the board creating a tendency to rotate like this is known as torque. Torque is something a surfer constantly fights when surfing because of the chaotic motion of the waves pushing the board from all sides. To fight this, a surfer must learn to apply their weight in a particular direction and location to create torque in the opposite direction to counteract the force from the water. The last factor that goes into surfing is the waves themselves. Picking a wave with all the right factors can lead to a successful surf. Choosing a big wave that breaks rhythmically rather than all at one time is more desirable because you want the most ride time out of the wave. A wave with a long wavelength breaks rhythmically and is a good wave.
Thanks for that information, dude.
Anytime, bruh.
I can't really do it. Yeah.
I'm gonna head on back to my little snooze sesh right quick.
Okay.
Stop.
Where is Morgan? Oh my god. Cannot find her.
My bad. I got lost in the vortex.
What's on your head?
My bad, bro. I mean, my bad.
Okay. Well, you missed a lot of our whole surfing bonanza, whatever it's called.
It's unfortunate.
But we're done.
Oh,
So thanks for being there.
Alright.
You still sound like a surfer. You know, Morgan, I think we've covered it.
I believe so.
I think we have covered it.
Yep.
So just remember, I'm Kalia,
And I'm Morgan.
and we're professional
Professional
scientists. Woo. Disclaimer, we are not actual scientists.
Nope.
We are just rookies. So most of the stuff we said in this video are probably physically correct.
These are fake.
This apron isn't even a real one.
It's for my kitchen.